Hey there, so today I'm going to be doing a video that's a little bit different than usual. I'm going to be talking about pull-up resistors. So it could get a little dry. I'm going to try and keep it moving quickly, but I want to explain how pull-up resistors work, some of the terminology involved, pull-ups, pull-downs, talking about built-in pull-ups, strong versus weak pull-ups, open collector or drain devices, things like that. So I'm going to go quickly. I'm not going to get heavy into math. I just really want to explain conceptually what this stuff is, because it was something that really kind of confused me when I was first starting out in electronics. So maybe I can help with that learning curve for other people. Okay, so first up, I'm going to be talking about pull-up resistors mostly with regard to interfacing them to GPIO pins. So whether that's a GPIO pin on an Arduino, a Raspberry Pi, a Node MCU, doesn't really matter. The theory holds true no matter what. Okay, so first let's just draw a generic microcontroller. I'll call it an MCU, microcontroller unit. And let's just have a GPIO pin off of the side of it, okay? So a common thing you might want to do is just interface this to a button or a switch. So let's draw the circuit diagram for just a button, and let's connect it to ground. That's the symbol for ground, and there's the symbol for a button. Okay, so when we hit the button, this is going to connect the circuit straight to ground. Okay, so this will look like it's just a straight connection to ground here to the GPIO. Right? But what happens when the button is not pressed? Well, what you really have here is just a connection to nothing. This is what we call floating. So really what you've done here is you've connected a very small antenna to a GPIO pin. So what will the state of the GPIO pin be if you read it? Well, we don't know. It's floating. It's indeterminate. Could be a 1, could be a 0, who knows? So what we do to fix that problem is we use let's just tie it to 5 volts, a pull-up resistor. So this basically sets the default state for the pin. So let me draw my button back in. Okay, so when the button is not pressed, this pull-up resistor will pull the voltage up to 5 volts in this case, whatever supply you tie the other side of the resistor to. So when the button isn't pressed, you're going to get a logical 1 or 5 volts at this GPIO pin, so you know what the state will be. Whereas before, without the pull-up resistor, could have been a 1, could have been a 0, who knows? Okay, now another term you might hear is pull-down resistor. So this is the same thing, except the resistor is connected to ground. So you can basically set the default state of the GPIO pin to ground or 0 volts. Okay, so there's pull-up and pull-down resistors. Next up, let's talk through strong versus weak pull-ups. So you can make a pull-up resistor just about anything you want. Common value might be between 1 kilo ohm and 10 kilo ohms. The weak versus strong is kind of inverse of that. So in other words, if you have a high resistor value, that is a weak pull-up. The reason for that is basically the larger the resistor value here, the less current will flow from here to here, which will affect how quickly it will pull that voltage up to 5 volts. So a weak pull-up will pull that voltage up to 5 volts more slowly than a strong pull-up. So a 1 kilo ohm resistor might be a strong pull-up. 100 kilo ohm resistor might be a weak pull-up. Okay, so that's what we mean by strong versus weak. Okay, so now there's another caveat to this. Let me erase my pull-up resistor here. So here we still have the button connected, but no pull-up. Let me get rid of this too. Now most microcontrollers or anything with GPIO pins often have built-in pull-up or pull-down resistors. So what that means is, really, before I had the resistor here external to the microcontroller, but if we kind of draw the internals of the microcontroller on the inside, you basically have a built-in pull-up you can enable. Now this is enabled via software. So for instance, in Arduino, when you set the pin mode to input, there's another constant you can use, and you can say pin mode input underscore pull-up, and that will actually enable that internal pull-up resistor. So sometimes you don't want that internal pull-up resistor, but sometimes it's really handy to have it built into the chip, so you don't have to put an extra resistor on the outside. So now usually those internal built-in pull-ups are what we call weak pull-ups, as I explained before. They're high resistor values usually, but check the data sheet for whatever device you're using, and it will explain what the value of those pull-ups are and how to enable them and all that sort of thing. So this is a really handy feature. Also note that some chips actually have pull-ups and pull-downs, so you can choose whether you want to pull up or down on that particular GPIO pin. So a very handy feature. Okay, so now let's talk about open collectors. So sometimes you'll hear this term open collector, and really what that means is that there is a transistor connected to your or inside of your device, and for our purposes, we're not going to get into how transistors work too much, but for our purposes, that basically is just an electronically controlled switch. So you can think of it like a button or a switch, where it can either be open, meaning no current is flowing here, or it can be closed, basically electrically connecting this line to ground. Usually it's to ground. So, but you'll notice this looked like our first example where there's no pull-up resistor. So that's basically what an open collector means, is that there's a switch, but there's no pull-up resistor. So let's pretend like this is a sensor, like a motion detector. So basically that switch is going to turn on when it detects motion. Okay? So what we need to do here is we need to, surprise, surprise, add a pull-up resistor. So that way, when this transistor is not on, meaning this isn't connected to ground, we'll have something to pull it up to a known voltage. So there's a lot of devices that are sold, sensors, everything that uses an I2C bus basically has an open collector style of output. And so, so you'll see this a lot. You always need some kind of resistor, pull-up resistor, either an internal one or an external one. So you might ask, like, well, why do they sell devices that can't drive a high voltage, like that are basically like half of the solution here? Well, there's a couple of very good reasons actually. The first is that if I have, let's see, my fictitious motion sensor here, with the open collector output. If I'm connecting it to a microcontroller that's running on 5 volts, there's a wasp in here, then I can basically just set a pull-up resistor to 5 volts. If I'm connecting it to a device that runs on 3.3 volts, I can just do a pull-up resistor to 3.3 volts. So basically, the same sensor will work on basically any voltage system you want to run it on. So you can basically set the high voltage value that the device will use by using a pull-up resistor, which is pretty cool. Let's see, there's another kind of cool reason that you might want to use an open collector device, and that's that you can actually connect multiple open collector devices on the same GPIO pin. So again, using our example of a motion sensor, let's say you wanted to connect several motion detectors to one GPIO pin. So basically you want to know when any of those when any of those motion detectors are triggered. Well, you can do that with an open collector because there's no problem. So if this motion detector triggers, it will connect this to ground and the GPIO line will be ground. If neither of these motion detectors are triggered, then the pull-up resistor will pull it high. So basically if you see a high voltage, you know there's no motion detected. If you see a low voltage, there's motion detected on one or more of these sensors. So it basically gives you a logical NOR operation, or not or, which is really useful. If you think about the alternative where you have a device that is setting at high voltage, either high or low, well, you have to think about the scenario of what if one device is trying to put out 5 volts or on this line, and the other device is trying to set it to ground or 0 volts. Well, what happens? Well, maybe that'll be 2.5 volts seen on this GPIO pin, and maybe that's enough to trigger a high voltage, maybe it's not. There could even be damage done because you have two devices trying to drive the same wire to two different voltages, which can lead to unpredictable results. So basically you can't really connect together one wire with two things that are trying to drive it at the same time. But with an open collector system, you can do that, which is pretty cool. So that's a good feature. So anyway, so open collectors are cool. Also make note, open drain is another word that they'll use, which really just means a different kind of transistor here, but it works the same way. So open collector or open drain for our purposes are basically the same thing. Yeah, so anyway, I hope this has been helpful. Let me know in the comments if there are other questions you have related to pull-up resistors, and I'll see you on the next video.